relocated. And my talk today will be about how we actually try to run through over 65,000 teams. And maybe in the beginning, can I have a show of hands who have used Jira? Okay, so that's nearly all of you. For those who don't know, it's basically a planning software, and this won't be a marketing show or something. That's the only slide that I have of all of our products. So yeah, it's basically like boards, edge, or whatever you want to do. So what I mean with not screwing 65,000 teams is actually how do we try to not ship any bugs to production. And of course, shipping no bugs to production is illusionary, right? But at least how do we get it to a minimum? And before I tell you what we actually do, I want to give you a little bit of context where we come from and why we do certain things, and why we need it to be on a bigger scale than most smaller companies do. So Jira itself wasn't even only a server product. So people could download it, host it, whatever. And then a few years later, Atlassian thought it would be a good idea to also offer a cloud solution, which in the beginning was just a server product hosted by Atlassian in its own data center and one tenant on a single virtual machine. As you can imagine, that doesn't scale well, so a few years back they decided to actually merge that thing into multi-tenanted architecture that's running on AWS. And since then, we've gone from a single service that's still there, so that the original service a little bit smaller, to a microservice architecture with services owned by a Jira organization and others. So we're actually in a kind of very big scale architecture with running in multiple regions, from Europe to US to APAC, multiple availability zones, and so on. At the moment, we, in the Jira Cloud family, we think about 3 environments that we apply to. It's kind of a typical model, I think, that a lot of you will be familiar with. So there will be staging, which we run testing instances, and dogfooding for Jira teams specifically. And then we have the dogfooding instance, which we think about as instances that run in our production environment. Where customer instances run as well, but those tenants are owned by Atlassian. So we do that in order to do pre-testing, and if there would be a bug in that environment, then it only affects us. And after that, or the rest of the production environment would be customer tenants only. We also came a long way from deploying, so at the moment it's basically continuous deployment. So we have big repositories, and on most of them it's automatic deployment through to production if all the tests and subtypes go through without problems. So that could be multiple times a day. And with that, the problem is that if you merge something into master, so the main development branch, you don't know if it's going to production and when. And we also do that on different services now, so it's different repositories, different services. At one point, you have to make sure that the product in the end doesn't break for customers. So that's the context from the technical side. But then, if you release features, there's also a personal side and a working together side. So there's multiple roles involved, and I didn't call this people because if you're a startup, it could be that all of those roles are in one person, or if you're a small team running a service, those roles would be in your team. The roles that I'm talking about, for some services that we run are in different organizations and continents. So sharing information with them is actually quite hard. And I will start with non-technical roles, or non-developer roles. So for us, we have support engineers, which the concept is probably very familiar to all of you. So it's colleagues of us that take care of customer tickets, trying to solve the problems, answer their questions, and so on. So if you release features, and as I said, we can ship or release our deployment multiple times a day, it's really hard for them to keep track what's actually changing in the product. If you're probably a support engineer in Brazil, but we're in Sydney developing. So for them, when they think about releases, they have some questions like, what do we actually ship at the moment? And how does the feature work? And maybe the development team knows that there are still some limitations because it's an early stage that we ship the feature with. However, there's still some edge cases and problems that customers might run into. And if that happens, support engineers might also want to know how they can roll the feature back for just one tenant or for the whole environment in order to unblock our customers to do their day-to-day job. And a similar thing happens for site reliability engineers. They are the ones who take care of the services, keeping them up and running, keeping them smooth and performing. So if we ship something that changes the load on a service or the data usage or memory usage, that could have a big impact on them. So they have a different set of questions because their needs are way more urgent when you ship something than support engineers. So for them, it's, for example, what if there's a problem? Can we detect very fast that something is not as we expect it to be? Or if we ship a totally new feature or something more complicated, maybe a migration, do we know the impact that they will have on the infrastructure? And did we cater for that in order to not influence the running system? And they have one question is basically the same, which is if there's a problem with the feature, they want to know how to roll it back as well as soon as possible without actually trying to find a developer to do it for them. And the last role is basically development itself. So those are the teams from engineers to product managers, all of them together, to actually work on the feature to try to get new things out for our customers. And because they know what the feature is, they don't ask questions about that. But their job is not releasing, right? Their job is actually building something that enhances the product and makes it better. So for them, it's more important to see that it's not much effort to do this tedious job of actually doing all the things around building new features. Or if they do bug fixes, it's very important for them to try it for one tenant or one single user in any of the environments. So there's a question of how flexible can we actually bring features to customers. And then because we're quite a big organization and multiple products in one family, are there any best practices, things that other teams learned that we can apply to our release process? And with those three roles in mind and the technical restrictions or situation that we have, I want to tell you a little bit how this will go from a development's perspective. So yeah, it's basically the day-to-day job as developers. And so let's say a scenario where we work on a feature that is a multi-month project. And we're in the middle of coding, it's the end of the sprint, so we actually want to merge things to master. But as I told you before, in the situation that we're in, every commit to master can actually ship to production. So even if it's a bug-free code, maybe we don't want that code to be run on production. So how do we actually merge to master to finish our stuff up, but not influencing the one? And we use a concept that's called feature flags, but you can also say feature toggles. So it's basically a design pattern that allows you to ship something to a code base and not actually using that code. And if you don't know how that is, it's basically very simple. It's just you would have some Boolean value, and you're asking an if condition if you should run a new code, and if you do, you just run it, and if you don't, you run either existing code, or if it's totally a new feature, you do nothing. Those feature flags could be a Boolean value, could be numbers, strings, anything that you want basically. And you could define it in source code, but then that restricts you from actually enabling features without deploying. Or you put them in system variables or environment variables in the virtual machine. But then you would have to set that feature flag on every virtual machine. Thinking about the feature flag system and running a service from multiple thousand tenants brings us to a lot of some requirements that we have. And first of all, it should be very easy to use for the developers that set those things up. So if I create a new service, or if I want to create a feature flag for an existing service, it should be super easy to integrate. So you want to have the minimal effort to actually set that up. As I said before, there's a big notion for us to be very flexible in how we roll out things. And I come back to that later about the possibilities that we want to have. On the other hand, checking feature flags on every request should be super fast. So we talk about multiple hundred feature flags being active at the same time in Jira, being able to be turned on and off because of ongoing development. So if we would have to query that data a lot and impact that request by a few hundred milliseconds, that would be not negotiable. So it should be in the lower 10 single digit milliseconds. And lastly, it should be super easy to roll back a feature if you need to. If it's an incident affecting all the customers, if it's just a single customer, any person that is in any of the roles that I talked about from any office in the world should be able to do that. And in order to do all those things, we use a product that's called Sparkly, which is a cloud offering that just does feature flag configuration. And this is an actual feature flag that I worked on. And you don't have to look through all the things because I will go on some things that you can do on it. First of all, on top there's big kill switch, which is great for support engineers or site reliability engineers if there's an incident going on. So with that, you can basically turn the feature flag on and off for a whole environment like production or staging. Then there's a section where you can configure multiple rules for either single tenants, multiple tenants, groups of users. It's very, very flexible. You can also assign different values for different tenants if you have a non-Boolean feature flag and so on. And if you're rolling a feature out, maybe you don't want to ship it to all of the customers at once because you don't know if there are some edge cases. So it's maybe better to do a percentage rollout. So just with the slider, we can define how many tenants will see this in the future. And with this concept, it basically allows us in our development process to merge the master and enable a feature at any given point in time. And let's say in our development, we're nearly ready with the whole feature, and now it's about how do we actually know what's going on in production. So this is where monitoring comes into place, which probably most of you will do as well in their software and products. And for us, it's about three big things that we try to monitor. It's about usage. So if it's a new feature that we do, or if it's replacing an existing one, it's interesting to see if the expectations that we have to the feature are actually met, or if customers can't discover it. The obvious thing is error monitoring, like exceptions, problems with services, and so on. And the last big thing that we try to monitor all the time, and we get alerted on as well, is performance. So we actually try to bring the best performance possible, which is also the biggest complaint that we have, unfortunately. So and with that, so basically we use multiple tools, but I wanted to show you 3 tools that, at least for my day-to-day work, with analyzing problems and so on, are the most important ones. And the first one is Splunk. Others might know Kibana or something. It's basically a log aggregator. So we basically it's awesome for querying any log messages from any service. Unfortunately for us, we ingest so many logs from the services into the system that we can only keep a few weeks of data in Splunk. So this is not great for doing long-term research, and it's also not great for doing alerting on a real-time scale. So this is what I would use day to day when there are any problems or I need to analyze any logs that are from any service. Then we have Signal of X, which the other tool that would be in the same category would be Datadog, if some of you would be familiar. So that's basically a metric aggregator. So you would put metrics into Signal of X from AWS, which would be like host counts, usage of queues, databases, and so on. You also push JVM metrics in there, like thread counts, garbage collection times, and so on. And user-defined metrics from services that better describe the workflows of a service or a whole feature. And on those metrics, you can actually put monitors and then automatically alert people either if it's not an important event on Slack or any other chat tool that's integrated with SignalFX. Or you can use an alerting tool like Upstream to actually page somebody to that there's something to be taken care of. And the last tool that I want to show that we use is Amplitude. And in Amplitude, we put analytics that we collect from the usage of our services. And to be clear, the analytics that we actually use are anonymized, right? So we don't care about who user did what. It's more about what do users do in general. Like which screens do they view, which click flows do they have. Maybe they don't find an easier way that is in the product to do a certain thing. And with that, we try to help people to use our products better and improve the usability overall. And in this case, it's a rollout of a refactor of a page, and it's only on an internal instance. So we would see that at this point in time, I actually enable a feature flag to show the new page instead of the old one. And then you see the view go up, which would be the blue line. And then at the bottom, we would see the usage of buttons for certain actions on the page. And so with all that monitoring in place, that's awesome for the development team. But at that point in time, we still didn't share that information with any other team. It's not shared how the feature and the feature flag and the monitoring dashboards belong together. So, and this is a real problem because there are hundreds or thousands of dashboards in those tools. And there are about as I said, about 400 active feature flags at the same time, and what are actually enabled that are not coming up at the moment. So in order to bring all that information together, we created a Jira project that's called the Feature Delivery Project, and that contains feature delivery tickets. And so what we try to do there is to give a comprehensive view of a feature that's going to be shipped. And it's just a regular Jira software issue, and it has a lot of custom fields. And I want to go through some of them to show you what information you collect there. First, it's the relevant people who are involved in this feature. So the assignee would be the main responsible. And then we would also have the product manager who takes the customer's view on that feature. Then we have the content designer who takes care of documentation for that feature. That's not public docs. And then some responsible people from support. We also want to have a brief description and a status if the feature is at the moment in rollout, or such like in this case, we're actually done with this feature and it's rolled out to 100%, and all feature flags are cleaned up. Then this would be what customers see when we release the feature. We generate with this content a blog post of all the features that are shipped. In order to let other people know when the features actually roll out, we want to have a brief description of the plan, how we do this. So in this feature's case, we first deploy to staging and let it soak there for a longer time, or maybe we continue development on staging. And then after, hello is one of our dogfooding instances. So we actually deploy it there. And let it soak for a few days before we actually started to ship to customers. And then we didn't ship to 100% at once, like we did a 3-step thing from 10% to 50% to 100%. When doing this rollout, the feature flags will also be linked here with the current status. As I said, this is already a rollout feature, but on a later slide I will show you how this will look like. And that status will be automatically updated from launch startup. And we also link all the relevant dashboards so that if people have a problem or people want to know how we actually think the monitoring should be for this feature, can actually access those resources. And the last thing that we do that is a little bit of a bigger effort is documentation that we call support readiness documentation. So it's an internal documentation that we do for support and site reliability engineering, and contains, for example, database tables that we use in this feature, limitations, problems, anything that will help support to actually help our customers without waiting for development teams to answer. So now we have the feature delivery ticket, and it's very well documented. It's awesome. We think it's the best one ever. But how do other people find it? Because at the moment we have over 8,000 feature delivery tickets already, Most of them, of course, the status down, but still, it's a lot of tickets at the same time because some features are longer, multiple months projects. And that's where the first time we release something to the customers, everybody has to go to a meeting that we call a chopper meeting. And that's where if you don't go there and you light a feature flag, like that means you enable it in production, it will basically be disabled the same day. So you should better go there if you want to release something. And it's basically the main purpose is to be the last quality day before we ship to customers, but also to share knowledge, what different teams do and what should be the necessary. That meeting is every day at the same day, and it's at the moment in Poland and in Sydney because we develop in multiple time zones. And it's the feature leads or the feature responsible going there and showing what they implemented with the feature delivery ticket, and also showing them what they try to monitor, and so get a better understanding. But it's not only about that, it's also about how they want to roll out. So maybe it's a very risky feature or it's a core functionality that you try to check something. So a rollout to what we've seen before, 10%, 50%, 100% in 3 days is maybe not a good idea. Maybe it should be a multi-month rollout. Also with the monitoring, site reliability engineers have a very different view on what should be monitored and whatnot. So in order to get their idea as well of problems that they might have seen in the past, but that development team didn't see it so far, it's also good that they look at that function. And so, as some of you know, it's very difficult to open a page and load something all the time in a meeting. It's very time consuming. And in order to not do that, we set a certain custom field in that feature delivery ticket. And on that day, we will copy some fields into an intranet page. And so all the feature flags that are feature delivery tickets that will be talked about will be on one page, and so you can just scroll through and have a very efficient meeting. And it's the same fields basically as before, a smaller set of it as before. It's the description, monitoring dashboards, the rollout plan, what's the public documentation. And then over there, we actually see what would have been in the feature delivery ticket if it would have been in rollout. So we would see which environments the feature flags are on and what state it is in. So in this case, it's fully rolled out and not fully, but it's only 10% of production customers. So after you successfully pass the quality gate, you basically can enable the feature flag as you want, and then in the rollout plan that you decided to do, ship to 100%. But that's not where a feature rollout stops for us. So after that's rolled out for a while, we're very confident that there's that this feature will not cause an incident. Then you actually have to clean up your feature flags again, remove the old code if there is any, and then be done with it. And then you're happy and can start with the feature. Any questions about that?
I'll take the lead. How do you make sure the feature flags or the feature code is then cleaned up after you actually turn the feature on 100%? Do we have a follow-up process with the developers so that we make sure?
Yes. So basically, if it's rolled out to 100%, this status will be in tiding. And then you have a bot that basically every week sends you a message on Slack till you sign the ticket and tells you that you should pick up the feature flag, or that the feature flag is not used for a long time and you should clean it up. Then it actively bugs you every week.
So actively pushing the...
Yes, because people won't do it otherwise. Right?
Yeah, exactly.
Okay. So let's say I'm working on a certain feature and I did not include any feature flags and I just pushed to master, and I'm allowed to do that.
Yes.
So where's the gateway to prevent this code from going to live on all of the instances?
So for us, all of our code has to be reviewed before merging to master, and that's the only quality gate there is. So if you bribe somebody to just review the code and say yes, it's approved, then you can do that. The bigger question is, so that's, I mean, we trust the developers in a way that every code that can be feature flagged will be, and that's basically the model that we go with. Of course, there are things that can't be merged, but the problem with that is, and if you're in one of those cases where this happens, you will not do that anymore. So deploying to production for us is still I don't know the exact time. So let's say it's a 1 hour thing, right? Then if you detect an incident or a bug in production and you want to roll back, you would have to roll back to a previous version. So that would be at least a 1 hour time slot, and you don't know how many people are affected. Worst case, it's a data loss, so you would have to tell customers or somebody from our company, hey, all of you will lose about 1 hour of this data. And if you would have the feature flag, maybe it takes some time until you notice the bug, but at least you can turn it off immediately. And then the other problem is, so if we release multiple times, maybe you can't roll back to the version where this bug doesn't exist anymore. So then you can only hotfix, and this is a risk as well. So there's
How do you deal with the features that involve multiple repositories? They can be controlled through the same feature?
Yeah. So basically, how this works, that launch royalty is an external repository. So you would have that configuration, and then we have SDKs. So launch royalty itself provides SDKs, but we wrote some wrappers around those SDKs. So basically, you can query the same feature flag from multiple repositories or multiple services. Then there's also what I didn't say before. We can also configure that there's dependencies between feature flags. So maybe you work on a very big thing and you need to roll it out in multiple stages, so you can make sure that the later stage is not enabled for a customer before the previous stage is enabled. So it's very flexible, but it also can be super complicated if you do too many feature flags that depend on each other and so on.
The question might be a bit too technical, but I see that you have a bunch of granularity on what things you can set as rules for having access or not to a certain feature. Will that not affect the performance of when you are retrieving a certain piece of the application?
No, it doesn't at the moment. So the question was if we set specific rules, if that affects performance. I don't know if when that would really affect it, but we didn't have the problem so far.
Okay.
But so what we do, I think the biggest flag that I know, it's one that we use, it's a permanent flag, and it's used to enable certain more detailed logging. For example, how many database queries are executed on a single request or something. And that one has probably 30 or so of those single rules, but we tend to try to not do that for regular flags. So the typical thing is that we don't have something like this at all, maybe just for our dog fooding environment, but then we only do that percentage rollout. And then keep it as simple as possible. Same on staging, it's maybe 1, 2, 3 instances that we test things special, and then the rest will be enabled or disabled for the whole environment.
The percentage rollout is controlled through here, or it's a different process?
No, it's here.
Just here, okay.
Yeah. I mean, it's the same thing. So Atlassian is a very open company. So I can access all the feature flags from Jira Cloud, and I can enable and disable all of them if I want. So there's no access control between teams or something. But that's the responsibilities of people, that you only do what you own, right? And there was no problem so far with filling in other feature flags. What I can say, because it's, I did the same talk actually last week, and then people asked how much effort is that whole process. Because it seems like a lot, but on a medium-sized feature, this will probably take 2 hours to do all of the things that you need to do to ship. If you have bigger features where you have to do more documentation and stuff, of course it's more effort, but like setting up most of the things is super quick, and it's supported by automated things. So for example, if I create a feature flag in launch directly, this will trigger the feature delivery ticket creation. So I just need to fill it out and then to go to the project and stuff like that.
How many developers do you have, and how often do you release the features?
Yes, so we release features every day. So there's exceptions, like we do have certain rules. If there's a holiday in one of the big development offices that we don't ship just because people are not available in the office. And it would be unfair to those people to ship a lot of features and then they're on call and they have to come into the office and fix something. With developers, I don't know how many work in Jira, but it's more than 100, definitely. So what I don't know across our products, because it's also in multiple offices nowadays. So it's nice. So with basically with Jira Cloud, we count Jira Software, Jira Service Desk, and Jira Core, which are 3 different product teams, and all of them. And then there's a Jira Platform team that does some basic things that are common to all of them. Yeah, but easy more than 100. Probably a lot more.
As you said, it's like all the feature flags has immediate effect, but is there some feature flag that takes some time to have effect and it can impact their production environment, like take like 1 hour, 2 hours, and have to restart a lot of services, something like that?
So yes, there can be a delay, but we never experienced it to be very long, so it's not noticeable. But as any cloud service, large directory can be not available from our services, right? So even if a feature flag is turned on for you, maybe we can't reach the service. So that's why we also define default values in source. So that's basically said if you can't reach the service, it's turned off or it's turned on. This can be tricky for you as developers because if you say it's 100% remote and you don't switch that value in source and it's false and the service is not available, maybe some things won't work anymore. Yeah, there's some trickiness, but that's I think the cost that you pay when you work in a cloud environment. Yeah, then, thanks for the questions and everything. I'll stick around anyway, so.
Hello, my name is Joseph from Atlassian. First of all, thank you all for being here, and thank you, Linus, for inviting me. It's really a pleasure to just give you some of my thoughts on this the development of this company. And theme today it will be the infrastructural challenges of a startup and how we went from the start to today. First of all, let me tell you a little bit more about the company. Our name is 360 Imprimir, or 360 Online Print in some international markets. We are an online printing company, but usually what we want to be is a one-stop shop for marketing products for small and medium businesses. So what we did is we leverage on existing capacity of printing factories and also on freelance designers to deliver products to small and medium businesses. So we are the marketplace that connects both of them, the small and medium businesses essentially, and also the printing factories that have capacity. So what we create is the software that delivers that. Everything that comes from point A to selling the client the product, to the client, to delivering, to the client, the billing, the payment systems, everything is handled by us with a lot of technology, a lot of algorithms and everything. We were founded in 2013 and we've been growing since then. We almost every year we doubled the size of our revenue and we expect to end this year with 35 million euros in revenue. But today we already are in 21 markets. All of them very different, but this is the end of the story. So I want to talk to you about the journey. This is how the story ends. So let's talk about the beginning. The year was 2013. And we were in Portugal in the middle of a debt crisis. And 6 young crazy guys left their jobs to create a company, a printing company. No one really knows about printing, so we just 3 IT guys and 3 guys with managing skills. So in terms of IT and infrastructure, we were supported by Microsoft with their Microsoft Spark program. This program that does not exist in the same terms anymore, but at that point in time they gave us 100 euros per month to spend on Azure infrastructure. And also they gave us all the software that we need to start building the company. But I took this picture just yesterday. 6 years ago, there were not that many data centers in Europe. It was only one, West Europe. That's where we started. And this is our first infrastructure. That's our starting point for our conversation for today. This is our project. It's not anything wonderful. It's just a virtual machine with the website in there and a SQL database. So I think most of the projects started like this, and we were no different at all. That's the difference. Maybe we have a storage disk that we keep the files from our clients. And it was our infrastructure for Portugal. And the next year, we started already selling in Spain, and we used the same infrastructure because Spain is just like here. The web server also serves, the data center also serves Spain, so why change anything? If it works, let's start. And the following year, we entered selling in Brazil. Brazil is maybe our first decision, our decision that we had to take on in terms of infrastructure, because it's impossible to sell in Brazil having a server in Europe. So what we have 2 options: create a multi-tenant application, or just go with the splitting the software into a different and independent structure in Brazil. We opted for the second one because we want to focus on product. That was our main focus when we are only 1 or 2 years old, when we were only 3 developers. And we split the infrastructure with independent servers and also the SQL databases. And one thing you might notice is that we chose East US to host our infrastructure in Brazil. That is especially more strange if you notice that it's a Brazilian data center in Brazil. That doesn't make sense. And it was already there in 2015. So what did we notice? We noticed that the Brazilian data center is not stable. It was not stable in 2015 and is not stable today, because I took this picture yesterday. So, of course, this image is from the latency from Portugal to the Brazilian data center, but of course it will be worse. But in 2015, we took the same test with a person inside Brazil, and he said, of course, that Brazilian data center was a little bit quicker, but the latency problems, this going up and down, it's already the same at that time already. So, as all of our team at that time, and even today, is based in Portugal. So all of our operation is based in Portugal. It was very difficult for us to access our web server in the data center of Brazil. That's why we choose to keep the US data center, because it's better for us, it's almost the same for them, so it's a better decision. That's what I did. 2016, we entered in Mexico. We took the same approach that we had in the year before in Brazil about Mexico, because even they are kind of in the same area, they are very, very apart. It's not the same country. They have different payment systems, different delivery systems, different production sites. So it's a whole market for itself, and it's not very intelligent to aggregate them into an infrastructure. What we did the same thing we did in Brazil. So we split it, and we have 3 different servers, 1 for each market, as we used to say. So right now, I think, damn, you are so bored. Nothing wonderful I didn't say to you until right now. And I think we should take that state of happiness to take some first conclusions. First of all, you need to think that this is a startup. We were only 2 developers. Roughly these years we're already 3 or 4. But we must focus on the first years of the company in growing the company and also in creating the product, developing the product, taking care of our clients. That's the main drive for the first years. The infrastructure, it's a means to an end. If it works, if it's okay, in the first years of the company, we'll not have millions of requests in the second. So don't complicate or overcomplicate things. If it works, and if it's okay, just do what you have to do and focus on other things because your time is valuable. And of course, this is nice, but there's a downside. The downside is that we created a lot of code debt, a giant monolith, and also a lot of in-memory operations, so we were not able to scale horizontally. And that's a big problem. First, of course, what happened is everything crashed. At some point in time when our revenue started to get bigger and our requests eventually hit that million of requests that I said to you, and everything crashed. That's where we started to addressing this issue. As I used to say, the monolith was only one virtual machine with one application with a lot of responsibilities, and this was everything to go wrong. I want to talk to you about one specific problem of our business. We are an e-commerce website. We sell things through online channels, but we are nothing like an e-commerce typical business because we don't have shelves, we don't have stocks. Every customer is a different customer. Every customer that comes to us with this image for his t-shirt, with this image for his logo, is a different company or a different client that we have to take address from the first period in time until we deliver the order to his home or his office. So what does this have to us? Every image that you upload and we have to treat them in order to be able to print them, it must be analyzed and prepared for them to have good quality to the client. So that's why we have so much image processing inside our front end. As a monolith, even the monolith needs image processing. That is not a nice thing to do because image processing operations are a lot of CPU intensive workload, and of course that will end up getting in front of our clients. That's where is the big problem. And of course, as I said in this example, a lot of file system dependency because the files of the clients needs to be kept for long periods of time. We started by solving the first problem that was the processing of images inside the front end. We took the monolith and split one part of the software and created a new application called Image Processor. This application is only responsible for handling the processing of images. It's only responsibility. And it is independent, of course, but we still had the problem of the shared file system. So if we have a file system to share a C or D drive, we don't have any possibility to have multiple virtual machines, and that's why we share the machine for a period of time. And that's the next thing we addressed, the file system dependency. The file system dependency, we gathered with Microsoft, with their engineering team, with their architectural team, to help us creating a solution for our problem. And they came up with a solution that is a recent technology at that time, I think 2016, that is called Soft. How does it work? We have two virtual machines with their independent storage, and they have a synchronous operation. When you write something, you write on both disks. So it is a lock-in system that when you write something, it does a log on the file. This has one major feature that is automatic failover. If something is broken, everything keeps up working flawless. But it worked for us for 1 year, and then again everything crashed. Took us a whole month to realize what is going wrong because the error was not consistent. There was not many details about this, and we also gathered Microsoft into this problem. And after a month, some guy in the United States said, "Soft, that doesn't work." Okay, thank you very much. Nice to say. Then because it is only designed for SQL servers. It's not designed for you in your business case, in your user case, that you have a lot of files that you read and write in the same time. So please don't use it. Okay? And then we entered to a older solution, a simple virtual machine with a data share. Very standard. Okay, but the truth is that with this solution, we were able to extract a lot of IOPs from the machine, and right now we have a lot of striping into those disks, and we have much more faster writes and reads that you had before, and we also have a replica. So in case of problem, we also can change the share from one server to the other, so we'll not be with the problem of losing files. Of course, this has a downside. It is an older technology, as I said before, and also you have to create your manual failover. Maybe this will have you one period of downtime in your infrastructure, but it's just in emergency. We hope we don't have to use it often. Right now, still 2 years has passed, and 1 year has passed, and we still not needed to do it. The issues we addressed is, of course, in memory operations. To create a stable and a scalable solution, we must be able to scale our front end. The rest of our front end we continue to improve. So what we did, of course, is development team created what is needed to be done in terms of codes for supporting removing these in-memory operations. Others needed this in-memory operation. That's why we created a Redis server to have low latency operations in memory. And we are able to finally create a high resilient solution with 2 or more front ends, which we chose HA proxy load balancer, not the typical Azure load balancer. I don't know if someone already worked with it, but it's much more powerful than Azure load balancer. It enables you to do a lot of configuration, something that is not possible to do in the Azure load balancer, for example. Of course, when we started this conversation, we had only one machine. We already are in 5. Of course, this costs a lot more. And especially if you have this multiplied by each market. But that's the price you need to pay for a high resilient solution. And that's something that we start to work upon that. What we did to minimize the cost, we started to melt some infrastructure. What we did in this particular case is we created an image processor. We created some shared resources between the Mexican website and the Brazilian website, especially the Azure Redis server, and also the image processor pool that serves both of the markets. And also with this solution, we have resiliency both on the front ends, also on these shared resources items. But if you think about all the things I've been telling you about our infrastructure, it's pretty clear, it's pretty obvious that we ended up with one of the most well-known anti-patterns of DevOps team, is to treat your infrastructure as pets, your machines as pets. Do you know, we already have names for them. One name, just, if you have names, it's a pet. So, you should do that if you want to scale a platform. Because it's really impossible for you when you have 100 to 100 machines take care of each and every one of them by himself. And of course, this must be a IT department decision. And what we wanted to do is to go to the microservices approach, like everyone. But of course, we feel that this is the best way to grow and to scale our company. Of course, that for us, it was a little bit more difficult because all our infrastructure was created in Windows, and Windows Docker containers don't work. Don't use it, except if you just doing it for educational purposes. If you need something for production, please never use a Windows container in Docker. And for us, what we had to do is to shift the paradigm from a Windows-based technology into we shifted from .NET to .NET Core. .NET Core is working on Docker containers with Linux, and besides that we added Kubernetes for orchestration, Ansible for the deployment process, and this symbol is the ARM templates of Azure in terms for that is used on creating the virtual machines that hosts the Docker containers. In terms of more specifically, this is what happens inside containerized approach. We still use the same HA proxy as load balancer, and we have a lot of these servers. They are ARM templates with Linux as hosts, and inside these hosts we have Docker containers. How much Docker container we need is how much Docker containers are in use at that point in time. If you need more, we still infrastructure. That's why it is scalable. If you need a new machine, just go on the ARM template, create the machine, and put it in the same load balancer region, and everything is okay. We created one region one infrastructure, one per region. One for Europe and one for the Latin markets. That's what you can see here. We're sharing the infrastructure between both of the markets in Latin, and also that's what we've been using so far. And the truth is, right, this year was maybe our biggest challenge. We entered in United States, Canada, and of course 15 countries in Europe. We are talking about all of the biggest European countries. So a lot of pressure in our infrastructure with a lot of new customers. And we started selling in April, and I am very glad to say that we are performing fine. Okay, so I think there is a proof of the working on our infrastructure and the things that we did in the previous 2 years to address all the issues that we have. This is the whole picture, okay, as it is right now, with the containers and everything. I might say that I sugarcoated the presentation. Of course, we have more virtual machines specific for some specific other tools, but it's not worthy of thinking about that. So, we're almost reaching the end of the presentation, and I want to do some conclusions about do's and the don'ts. So, first do, business survival is the drive. At the end of the day, it's not, you don't need to have a big infrastructure if you don't selling that much. So, first of all, just think about the country, the company, and focus on what the company needs and how the product is going to evolve. That's the main focus. Infrastructure, you will take them later when the problem starts to appear, when you start to feel that the problem might come. Of course, that's something that you should do, is to monitor and use data to validate architectural changes. Because when you are so eager on the first sentence, you might think, okay, you don't need infrastructure. Just put some more features, and you end up with some problems. And you should use data to validate your thoughts. If you are in doubt or that you must do something or you don't, just try to gather some data. Try to see if this development is worth it right now or maybe later. We're just calculating costs of the problem later and how it's going to take you for developing this feature right now. Azure vertical scale. That's what I should do is don't be ashamed of using vertical scale. Because if it suits, if it works, why not? Okay? In the first years, you may not have that much aggressive clients. So if you need to scale from one 4 CPU machine to an 8 to a 16, just do it and focus on what is important. Okay? Don't be ashamed of use, especially when you are talking about, oh, here it comes, Black Friday. Great, it's better for you. Also, one thing I would like to advise is continuous integration and continuous deployment. I still see a lot of companies with 10 and 15 years of developing a product. When I ask them, how do you do your deployment? They say, there is a guy that compiles and release, zips the file, put in the server, and zips, and that's okay. And I say, how do you manage? How can you do that? You will fail eventually. You will fail eventually, and a lot of problems will come after that. And it's a task that you will have to do a lot of times during the company. So you should start it's one of the tasks that you should take automation as much quicker as you can. Also, define processes with automation. This is kind of the same as before, but also for other parts of the development and also the team managing. If you have some processes that you need to do many often, okay, maybe you should try to make them automated. Okay, and also define processes even if these processes are not digital. Take a blank sheet with you. Have you done your code reviews today? Yes, in the first years of the first months of the company, it's better to make some team commitment. Also, you shouldn't don't postpone on hard decisions. That's difficult. I already talked about it earlier, but try to grab data to advise you and to make the better decisions. If you are not strongly confident with the decision, try to validate them using data as much as you can. More than 3 is a crowd. Also, it's almost. I used to say this. It's one of our biggest mistakes. When we started people coming inside the company, we didn't take that much attention in some organizations. So we didn't have Scrum and anything. We didn't do pull requests because we are only 2 or 3 and we completely were confident in each other's code. So we didn't remember to make this into some junior consultant people, some junior profiles. It was a mistake. You will pay that later, okay? And so after you have 3 people, start doing some code review. It will be better for you and your team to start doing this. Getting the word. I will remember later. And also, don't repeat tasks. You might do something once. You maybe do the same thing twice. If you're doing the same thing more than twice, it's probably you shouldn't do it. Okay? If just take a decision. If it's going to have a specific period of time that I'm going to do this manually, okay, I will do this for a whole week, 1 more week, 2 more weeks, 3 more weeks. Okay, I can maybe manage it, but try to figure out if something is going to take you a while, just automate it. In the end, I just wanted to have this quote from George Box that I really enjoyed it. In God we trust, all others must bring data, because at the end of the day, I think that's one of the most important things. things. Data, not only what I said, but also from monitoring our infrastructure and getting data to create events, to create alarmistic and everything. Okay? That's all. My contacts are there. I will put this presentation in Twitter. Of course, like everyone, we are hiring. And so if you like something and you want to talk to me, just talk. Some questions if you want.
So you have been reacting. When it hurts, you do the change. Is there any place that is, or any of the things that is hurting now, and that what is next? What is the next challenge, right?
Yes, I'm not that confident with this implementation. I think we should do better. I think we need to do better. Also, the deconstruction of the monolith is only a part of it. So it's something which I usually say that we are changing the wheel on moving. So you must change the wheel, the tire is flat, you must change the tire, but you cannot stop. So you will take a lot of time to do it. Much more time than if you stop to change the wheel. So that's some of the things that we still need to do to decouple the monolith into more microservices now.
So you've talked about decoupling the monolith and separating your code into microservice architecture, but do you ever face any problems scaling your database right now?
We still don't have, but we are very cautious about databases. Always going then to creating some indexes and everything. We are still on the scaling capability. We still are able to scale inside the Azure capabilities. So we still didn't have, but of course that is something that that sometimes is a problem. We already faced this. What can I say is that when you have problems, usually they are from bad coding. Okay, so bad coding leads into problems, not the database by himself. You know, it's just some operations that are not well thought. Maybe you are getting that data too much, and then you just fix the specific thing and move. We still didn't have that problem so far.
Did you ever try to use, for example, for the image processing, functions instead of services? I don't know how to call them Azure, but AWS it could be lambdas or something like that.
Yeah, it's you know it's much more difficult because we are talking about PDFs with specific needs. They have specific ISO codes for these PDFs. They must be done in PDF X1A to be printing ready, and very few software creates that kind of PDFs. We are talking about some code that runs on console applications. So in our APIs, we open a console application to run this tool that is custom and proprietary, and we pay a big fee to have them because there is not a lot of libraries to take this kind of things, and that's a problem that we in all of our infrastructure we still will always have this dark side. So thank you very much.